Arsenic, the essential poison for the semiconductor industry. Hey, engineering enthusiasts! Have you ever stopped to think how one of the most infamous poisons in history can also be a fundamental pillar of the technology we use every day? Arsenic, a name that evokes mystery and danger, hides a fascinating duality. It is a chemical element with a dark past, but a bright future, especially at the heart of our electronic devices. But after all, what exactly is arsenic, and how did it become so indispensable to the modern world? And here, I think it's worth making a distinction because actually, the chemical element is called arsenio and the poison is called arsenico. But what's the difference between the two? Arsenic, represented by the symbol As and with atomic number 33, is neither a typical metal nor a non-metal. It belongs to a special category of elements known as semimetals or metalloids. This means that it has intermediate characteristics and can behave sometimes like a metal, sometimes like a non-metal, depending on the conditions. This ambiguous nature is exactly what makes it so versatile and at the same time so dangerous. Imagine a chemical chameleon, capable of changing its properties to adapt to different situations. That's a good analogy for arsenic. Arsenic, on the other hand, usually refers to arsenic compounds, such as arsenic trioxide, the historic king of poisons. It is toxic to humans, causing severe damage, but it has also been used industrially and historically in medicine. In summary, arsenic is the pure chemical element, a gray, brittle metalloid found in soil, water, and minerals. And the term arsenic compounds refers to the inorganic or organic compounds of this element, with the inorganic ones, arsenites and arsenates, being extremely poisonous. But what are the properties that make arsenic so unique and useful? As I said, in its elemental form, arsenic is solid, brittle, usually gray, silvery, and it can sublimate. That is, it goes directly from the solid state to the gaseous state when heated, without melting. It reacts with other elements, forming a wide range of compounds, some of which are extremely toxic, while others are surprisingly stable and useful. Its ability to form covalent bonds with other elements is crucial for its applications, especially in electronics, where precision in electron conduction is everything. But how did an element with such a sinister reputation become known to us and become part of human history? The history of arsenic is long and full of twists and turns. Known since antiquity, its compounds were used by the Greeks and Romans mainly for pigments and, unfortunately, as poison. For centuries, arsenic was the silent weapon, hard to detect and deadly in small doses. Its discovery as a pure chemical element is attributed to Albertus Magnus in the 8th century, although its elemental nature was only fully understood much later. This long history of use and abuse has shaped the public perception of arsenic, but it did not stop science from discovering its potential. But as such a potent poison, it found its way into the most advanced industries of our time. The turning point for arsenic came with the advancement of materials, science, and electronics. Far from being just a poison, arsenic turned out to be a vital component in various industrial applications. Historically, it was used in pesticides and herbicides, but these applications have been discontinued or strictly regulated due to its toxicity. However, it is in the semiconductor industry that arsenic truly shines, showing a completely different side of its chemical personality. And what is the secret behind its importance in semiconductors? Arsenic is the key ingredient in a compound called gallium arsenide or GaAs. While silicon dominates most of the semiconductor industry, GaAs offers advantages in certain applications. Imagine that silicon is a reliable and economical car for everyday use, while GaAs is a high-performance sports car made for speed and specific tasks. GaAs is a compound semiconductor formed by combining gallium and arsenic, and its electronic properties are superior to those of silicon in several crucial aspects. But why is gallium arsenide so superior in some areas, and why is arsenic therefore essential? GaAs allows electrons to move much faster than in silicon, which makes it ideal for devices that operate at high frequencies, such as those found in wireless communication systems, radars, and satellites. In addition, unlike silicon, GaAs is a direct bandgap semiconductor, which means it can emit light efficiently. This property is essential for the manufacture of lasers, LEDs, and high-efficiency solar cells. Think about how 5G internet speed or the clarity of calls over fiber optic networks depend on components that process signals at incredible speeds. Often gas is behind this high performance. So why is arsenic so indispensable to modern industry despite its toxicity? The answer lies in its unique ability to give these electronic and optical properties to gallium arsenide. Without arsenic, we wouldn't have the same ability to build high-frequency devices and efficient light emitters, which drive telecommunications technology, high-speed internet, satellite navigation systems, and even the most advanced solar panel systems. It is the ingredient that allows electronics to go beyond the limits of silicon, opening doors to innovation that shapes our connected world. But if it is so useful, how do we deal with its inherent toxicity? The toxicity of arsenic is a serious concern, especially in its inorganic arsenic compounds, which are the most dangerous to human health. Exposure can cause a range of problems, from skin irritations to cancer and damage to vital organs. However, it's crucial to understand that in the semiconductor industry, arsenic is not handled carelessly. It is incorporated into stable compounds, such as gas, and processed in highly controlled environments, with protective equipment and strict safety protocols. It's like working with high-voltage electricity. It's dangerous if you don't respect it, but perfectly safe with the right precautions. Companies that use arsenic in semiconductor manufacturing invest heavily in ventilation systems, process encapsulation, constant air monitoring, and safe waste disposal. The goal is to minimize any risk of exposure for workers and for the environment. It is a clear example of how engineering and chemistry work together to tame a dangerous element and turn it into a valuable resource, always putting safety first. Nature is full of dualities, where what is dangerous in one context can be incredibly useful in another, as long as it is understood and handled with respect and intelligence. If you've made it this far and enjoyed the video, take a moment to subscribe if you haven't already, leave a like, and turn on the notification bell. And if you find our content interesting, consider becoming a member to help us keep producing content here on the platform and to get a mention in our videos. And if you've made it this far, I invite you to take a look at the courses we recommend. So point your phone at the QR code that's on the screen or click the link in the description for our courses. There you'll find Excel courses, 3D modeling AutoCAD, public speaking, and many others. And these are courses selected by us here on the channel, and we can vouch for their quality. And for those of you who want to start your online presence, start recording videos for social media, with this QR code, you'll find the equipment we use in our studios. And did you know about these properties of arsenic? What other dangerous substances might be waiting to be covered? If you're interested in learning more about the courses, let me know in the comments, because I want to know. And don't forget to leave a like, making sure you watch to expand your knowledge. And also subscribe to the channel and turn on notifications. If you want to support us, leave your like, subscribe to the channel, turn on the notification bell, and consider becoming a channel member. That's it, engineering lovers. Take care, and I'll see you in the next video.